Today we're back to a radio from 1981-82, and this one is a Harry Moss radio, and it's the PT325. What's it say on the back there? They're made in Korea, if I remember rightly. Harry Moss were behind the Harvard range, weren't they? Well, it's an independent chassis you won't see anywhere else. And on the printed circuit board, oops, it says PT325, so it's clearly made for this model. This is something I think we picked up in a batch of stuff off eBay, if not individually off eBay. Just turn the volume down on the monitor because I'm going into feedback. There we go. It's come in rather an unhygienic condition, to say the least. And what we have here, and for the other business, as you know, we're involved in huge pipe organ restorations, we actually have a dishwasher in the workshop, not for washing dishes, but for washing parts. So I've run the radio lids through the dishwasher. I've run the microphone, it's a standard outside mic, which is the kind of thing we would put on anyway. Run the microphone casing through the dishwasher, and we've run the sections of the front panel and the knobs through the dishwasher. Now it looks like a nice radio. Now, before applying power to it, always do an observation, and the first thing I can see is that capacitor there, where the sleeving has retracted, and that means it's been very, very hot indeed to do that. So normally you've got the sleeving which has the value on it, and this has, but it started to retract, so it's melted it. That means we need to change that capacitor. We're not going to try anything, we're not going to test anything. I will test the capacitor. I'll test it in front of you when I've whipped it out. It might work, but that's something typical which we need to get rid of before we do anything with a radio like this. So I'm going to unsolder that. I do have a photocopy of the instruction manual which came with these originally in 1982, and from that there was a circuit diagram in there, and we've been able to do a blow up of that, and from that and the radio in front of me I've been able to come up with an adjustment chart. So hopefully we'll be able to get this working. Now, another engineer's already looked at this whenever it arrived. He's got a red sticker on it, and that means it doesn't work. So I'm going to pause the video, we're going to whip out that capacitor and see what happens. Okay, so we've now whipped that out. I've observed the polarity. The negative was to the bottom. It's capacitor 20 according to that location. And when you actually have it out in front of you and start to look at it, you can see that it has indeed been very, very hot. So the next thing is, we'll see what it is. I don't know whether I can zoom in that far. .220 microfarads. Can't see the voltage. Anyway, whatever we put in above 16 volts will be okay. So 220 microvolts, it's capacitor 20 we said. I'll just look on the circuit diagram for that. And there on the circuit diagram is capacitor 20. And it's part of the audio IC circuit. So we'll get one of those plonked in and I'll be back with you. Okay, so I've put a new part in the radio. Meanwhile, I've got the old part hooked up to this test instrument, and I haven't tested this, so it might work, it might not work, but I wouldn't want it in any equipment I was going to be using. So we'll just zoom in on that, and we'll press the test button. Well, there you go. 8.9 picofarads, and it should be 220 microfarads, so it's absolutely open circuit. So there'd have been a nasty hum on the sound even if it had worked at all, or it would have been very, very distorted. And of course it can damage the audio IC with problems like that, with the load being wrong. So that goes in the vertical filing cabinet. I think it missed and went on the floor. Right, so back to the radio. I now feel that we can plug it in, and this we will do. Just plug it into the test instrument. Not only did we launder the microphone, but we put a new plug on that. It was the locking ring was missing, so I don't know why that was. There was a screw missing, locking ring missing. So we're plugged in, the power supply's on. We'll switch the radio on and see what happens. Okay, we'll select channel 20, and it's kind of receiving a strangled something or other. So that's a good start. It also proves I've wired the microphone correctly. It appears to be uniden wiring on this from the information I had. And we'll now just quickly pop it into transmit. And there is no transmit, it's dead. So we'll have to start fault finding that. The transmit lineup, as far as I can see, and it won't be an alignment problem, it will be a fault. The transmit lineup is L604, which is that one with the wax in it, L602, which is that one, sorry, L603, 604, 603, 602, that's that one, and 601, which is there. And then there's a variable capacitor on the antenna socket. Now what I'm going to quickly do as a fault finding aid is switch our monitor receiver on. And it's nothing into that either, so it's not generating the frequency by the sound of it in transmit. So I'll just do a bit of fault finding. Right, back with this. Actually another day. Been doing other things in between. I've got transmit on it. I went through the radio with a powerful light and a magnifying glass, and I've just been through it for dry joints. I've also changed a 0.47 microfarad capacitor, which wasn't faulty, but the legs were so corroded I thought it was they would probably snap off in the next few months. So that's a small electrolytic there. Right, so now we're going to transmit, and we have got 3 watts to the dot. So the first transmit coil was 604, if I remember rightly. I'm not expecting that to be out. No. Just turn that monitor down again, I've got feedback, there we go. The second coil, which I'm not expecting again to be messed with, is 603. I've just brought it up a fraction there actually. We've probably got 3.1 watts now. And the next one was 601. I'm doing the wrong one there. 601's behind there. That was one of the receive ones, wasn't it? Oh, well, that's a bit more of a melt. It's brought it up to 3.6 watts. Go for that variable capacitor. No advance on 3.6. Just have a look at that one again. Well, that's brought the power up to 3.9 watts. So I think that's where we're going to be with that. And remember, this is a commercial test set, so that probably equates to about 6 or 7 good buddy watts. So what have we got next, which we think we can do? Well, it's got a low power, and let's switch it to low power and see what we're doing. We're doing absolutely nothing. Chances are that the preset's dirty for a start, so we'll just spray that. I think it's RV5. Looking at my hastily scribbled notes. I'm still getting nothing, so I'll look into why that is. On the transmit meter, we're looking at it's RV4, and of course we should be getting 4 indication. It swings straight across. Let's see what that says. Oh, it's well over the top. So that now reads 4 on the meter. Okay. So frequency, it's slightly off frequency. It's neither here nor there. It's well within the tolerance. And what have we got? 27,79139. So it's just very slightly out, but we may as well adjust it. And the crystal trimmer is going to be next to the crystal there. There we go. C61 by the looks of things. Whichever way I adjust it, it'll be the wrong way. Right, well that was a bit of a problem. I said all we need to do is to adjust the frequency. But it turned out that the trimmer capacitor for the synthesizer there, for the local oscillator, we'll just zoom in on it. It turns out that that was broken. Physically, it was just, you could turn it, it was going round, but nothing was happening. It's a 40 picofarad one, and most sets are 20. So we've pulled one from stock, which is 40, and we've set that. But we've also discovered that, yes, you set the transmit with that one. When we come to receive, we have to set the receiver using this coil here with a marker oscillator. So that's going to put an added piece of complication in as we set up the receive. So, where were we? I think we've got deviation to do. So we'll get the oscillator out, go into transmit, and we have, it's a bit over the top at 3, so I'm just going to adjust that down again. And looking at my notes here, it's RV3. RV3 is there. And then we'll give it the whistle test. Just slightly over the top. There we go. That's spot on. So the only thing I've now got to sort out off camera is why we've not got a low power. So I'll come back to you in a moment. Yes, I've been able to replace the 500 ohm preset there, and that's now restored low power operation, which is now set for 400 milliwatts. So that concludes the transmit side of the Harry Moss PT325, I think we said it was. Right, we'll see you on the receive side of the video.